My name is Stephen Alonso, and I'm a flat earth scientist. I'm pushing the boundaries of where modern science has failed. I'm going where no one else before me has gone.
We're back, guys, with the final experiment, challenge number 3. I killed it with the first and second, and this time we're doing another very exciting one. What we're doing is determining the distances between the meridians of longitude. We're using Puntas Arenas again at negative 53 south, and for my test case, I just chose 1 degree over, so negative 70 longitude and negative 71 longitude. Now, the base of our formula relies on the meridian distance, and it's important that we derive this through just observational methods without having to rely on spherical assumptions. We don't want to have to assume that the Earth is a globe or anything like that. What happens is we know many ways, such as Polaris. We can look at star transit time, and even surveyors and ships, they know the triangular verification to know that the meridian distance is about 111 kilometers, or about 69 miles. Now in flat Earth, the calculation is very simple. We take this meridian distance and we we take the meridian distance and we multiply that by the cosine of the latitude. That's all it is. So in this example, it'd be 111.32 cosine of 53, 67 kilometers. So this is the flat Earth prediction for the distance between those two spots right up here. So on the world map, this is how it looks in real life, and it's going to be the distance roughly between, what would that be down there at the bottom? Is that a 4 and a 5 Roman numerals? The 60 and 75. So right in there, you can see it. And actually, I can zoom up a little bit more. I don't want to distort the map. Let's see what happens if I go to 5,000. No, it's not going to look good. But right down in there is where we'll be. Let's get back to this. Now the globe, though, when you have to assume a radius, derive additional assumptions based off of the first principles that we've already established, you get a slightly different and more complicated formula. The results? Well, the globe, they claim that the distance between those points will be about 66.9 kilometers. That's wrong. They're wrong by 110 meters. What does that allow us to conclude? Well, it lets us know that the flat Earth model is accurate, but not only that, it shows us how far the globe is off. Now again, I could be wrong. We won't know until we do the final experiment and see whose prediction is right. Does flat Earth make a better prediction, or does globe Earth make a better prediction when they assume spheres, or does the cosine function naturally describe the apparent spacing of meridians from an observer's perspective on this flat plane? We'll find out. Thank you all, and again, flat Earth, you gotta continue making these submissions. Right now it's only been me. But again, I have the Flat Earth Science textbook, which I read and study all day. I got James Stewart Calculus. So again, science and math is how we know the Earth is flat. I published now 3 papers in 2 days. I don't know what globers have done. I don't even think they're publishing their papers. They're trying to keep it hidden just in case they're wrong. They don't want any criticism at all. Whereas for me, I know that flat Earth is settled science. What I say here is fact, and globe has to compensate for that. The final experiment is going to show us that the distance between those 2 points is actually a little over 67 kilometers instead of the globe claim of 66.9. Thank you all. I'm Dr. Stephen Alonso of the Flat Earth University. You can enroll for free right now at students.flatearth.university. And if you want to also help fund my research, I sell this map as well for $25 US, and I'll ship it free almost anywhere in the world. And it's large. It's like a 60 centimeter by 90 centimeter canvas print. Thank you. Have a wonderful day and keep studying.
What is flat earth science? Well, it's asking the questions other people are too afraid to ask. It's the willingness to face any challenge, knowing that failure is how we get better. It's about testing our hypotheses using first principle concepts.